Alright, so today what we're going to do is we're going to kind of go on with geometry. Okay, there's a couple of definitions that we have to recognize. Okay, so for example, if we had a triangle like so, okay, when it comes to angles, you're going to see stuff like this, like little arc drawn. And when you have little arcs drawn like this, that means that this angle is equal to this angle. Alright? So, if we have all three angles, okay, we have all three angles, alright, that are the same, or we call congruent. This is what we call equilateral. Equilateral. So, pretty self-explanatory. It means all three sides are equal, which means all the angles are going to be equal. Okay? Alright. Now, what if we had, say, a triangle, right? Let's say that only two angles were congruent, right? If only two angles are congruent, then we call that isosceles. Alright? Actually, there's an S between the C. Isosceles triangle. So if we have only two angles that are congruent, then it's going to be isosceles. Okay? What if we had, let's see, what if we had just like, random triangle. However, none of the angles are congruent. Alright? If none of the angles are congruent, then we call that scalene. Okay. There's a couple more things we have to talk about with angles. So in a triangle, you can have three angles, and one of the angles can be less than 90 degrees. So for example, let's just say that none of the angles are congruent. However, none of the angles, none of the angles are, greater than 90 degrees. So in other words, all the angles of the triangle are less than 90 degrees. So if all the angles of a triangle are less than 90 degrees, then we say this is an acute triangle. Okay? An acute triangle. However, if we have a triangle that is greater than 90 degrees. So for example, this angle right here, we'll call this angle A, okay? So angle A, is going to be greater than 90 degrees. So if one of the angles, is greater than 90 degrees, then this whole triangle is what we call an obtuse triangle. Okay. So what we can do is we can combine, if the triangle is obtuse or acute, and if it's either equilateral, isosceles, scalene. Like for example, let's say that we had this triangle right here, okay? Oh, another thing is, in a triangle, if you want to show that the lengths of the sides are equal, then what they'll do is draw a line through each length. So what this is saying right here is that this side is equal to this side. However, if all, like, or if you have different sides, then what they do is they'll draw like two lines, indicating that this is not equal to that. And let's say if this line isn't equal to either two, then they'll draw three lines, indicating that all three lines are not equal. And if all three lines are not equal, that's what we call scaling. So in this case, what we're going to have here is kind of that idea. So over here we're going to have, alright. So if you look here, none of the sides are equal, right? Because they're all different lengths. So we already know that if that's the case, it's scaling. However, we're not done here. Just by visual, you have to know, okay, is this an obtuse triangle or an acute triangle? Well, let's look at each angle. So this angle, right? Well, let me not put that there, but anyways, like this angle right here, that's less than 90. This angle right here is less than 90. However, this angle right here is greater than 90. So if you have one angle greater than 90, then it becomes obtuse. So the whole answer is obtuse scaling.